Hi everyone. Today I'll be taking us through the measurement of staircase. I've gotten a lot of questions on how to go about measuring our staircase, and this video webinar is going to explain in detail how you can go about taking measurements for your staircase. And the first thing I want us to understand is that when you talk about your staircase as a structural member, staircase comprises of so many other items of work that are under it. So if you want to take off for a staircase, there are different things, there are different items of work that you look into, and there are different components that come together to make up staircase. For example, when you talk about the landing, you talk about the flight has the risers, it has the treads, and then we also have the half landing, we have the concrete beam that most times is always attached with that very landing. So there are so many things or so many items that comes together, so many item of work that are coming together to make up this very particular structural element, staircase. So but you have to understand that in taking measurement for your staircase work is majorly into three places. For now, we'll be talking about the measurement of our staircase in terms of the concrete work, institute concrete work. Then again, we will also be touching the area of reinforcement, but as it refers, as it concerns form work, we might not go into that. If you are able to take off for your concrete work and then you're able to take off for your reinforcement, then I see no reason why you shouldn't be able to take measurement for your form work. Then when you get to finishings, like taking measurement for your risers in terms of tiling or screeding, those are just smaller units of work that you can always do, but the basis is understanding how to take care of your concrete work and your reinforcement. So without any further ado, let me quickly show us how to go about measuring that. This is my plan, and these are my sections on this right hand side. You can see that this flight, the arrangement of this flight, that it has both the risers and the tread, and then we have the half landing, then we have the full landing leading to the first floor. The name on this drawing page is general arrangement of staircase, that is ground floor to first floor. All right, so if you want to measure for your concrete work, what you use in this case is your area tool. And why are you going to use the area tool? Because there are different parameters that you need to be able to cover up for your concrete work, and those parameters are your length, your breadth, and your thickness. Your thickness, as you can see, if I zoom in, you can see that our thickness as a concerns our flight or our string is 175 from this variant, but there is a way we're going to do it. The concrete work for your staircase, you take it off as a composite item. And what do I mean by that? You don't take off each of the risers and you don't take off for each of the threads, except if you are measuring for your threads and risers in terms of your finishings. All right, so for you to take care of your concrete work, you will have to take care of it in terms of a composite item of work. So let me go ahead and show us what I mean by that. Once I slide down on this my area 2 on the arrow pointing downwards, you can see we have different options, and one of them is the volume in cubic meter. This volume in cubic meter is what I need for me to be able to measure for my concrete work. So once I click on this, then you will see that the first form is asking me on the form, the first thing is asking me is the name of what I want to measure. This time it is my concrete work. Let me write in abbreviation, concrete work, okay, in parentheses, since my string is there, my risers is taken care of, and then landing. So I'll take measurement for all of these at once. Then the depth, I want to explain this depth so that it doesn't confuse you. You can actually customize. By default you will see depth here, but since we are measuring for staircase, you can see that from our plan that this length from here to here is 2725, and this 2725 is covering both the width of the flight, the boat flights. It covers for the width of this flight. So if you want to take off for a particular flight, this is the first flight and this is the second flight, you will have to take them individually. All right, so the depth here is not the thickness or depth of the flight or the thickness of the flight. The depth is referring to here is actually the length of each of the flights, that is from here to here. Let me call that the base or the width of the flight. Then we'll refer to this side, which is the slanting side, as our length. Okay, let me quickly show us how we can change this level from depth to length. So what you have to do is that you go to advanced, and on your advanced you can see our depth in millimeter. On this estimating group, this is our depth, and this depth you click and right click on it, go to properties, and then you can retype the name or change the name to be length. Okay, and then you hit OK, and when you refresh, you can see that what we have here is now the length. You can also check that from your form. So this is how your form is going to look like. All right, so if we consider this, then 275, you see this is more like a dogleg staircase, and in a dogleg staircase you see the space in between here, you have to consider it too. In most cases it is going to be 100, in some cases it's going to be 150, but for the sake of this webinar I'm going to take it as 100. And if I take it as 100, if I subtract 100 from 2725, it is going to be 2625. All right, and 2625 divide into 2, I'm going to have 1312.5, 1312.5, and my unit is in millimeter, so I'll enter that 1312.5, and I hit OK. Once I hit OK, for now what I want to take off for is flight. So I will click, just keep on clicking. You can see I've added something to that, but you can, that is you can ignore that for now. Then keep on clicking at the edges of this very step, or the steps. Okay, so keep on clicking until when you have covered everything as it relates to this very flight. Let me zoom out a bit. I think this is not difficult for anyone to take care of. Then you bring it down here, then this you can double click, and then that will be taken care of. Then we have our half landing, which is from here to this place. And then this is our beam. So for now we can leave that, but I have taken care of I've taken measurement for our flight and that of our half landing. Okay, then I can go ahead and measure for this side too. Okay, actually do something, but I just know that everyone knows why it is snapping to this. You can come down. If you turn off this, then you won't get, you know, this whole a lot of you know, trying to snap to the edges of each of them. But for me, I would like each of these edges to be well, you know, taken care of. So that is why I'm leaving my auto on. But if you turn that off, then you can make any shape with, you know, with your click. And I have just few places remaining. Okay, this is my my staircase base. You know, this is my staircase base. So let me just use this side to explain what I mean by turning the auto off. So once I click on this, I've turned the auto off. So you can see that I can easily, you know, click at any point that I want to click on. And once I double click, then this same flight have been taken care of. All right. Then you remember we've calculated for this very half landing so that you don't over measure. Okay, for now I will right click and stop. Another thing I want to take measurement for at this point is going to be my beam and my concrete base for the staircase. Okay, so if I zoom in, you can see that I have my beam, and just like I told you, the thickness of this beam is 0.3, and then the width is 0.23, while the length, you can always determine our length from here is running all through. And I discovered that I made a slight mistake while I was taking, you know, measurement for the flight. Please take note, this our dimension is in to in, so we were supposed to subtract, you know, half of 225 from here and half of 225. This is wall 225 according to the drawing, so you're going to subtract half of 225 and then half of 225 here, which is going to give you a total of 225, and then also subtract 100 before you will be able to divide into 2 to have the accurate dimension for this very width of your flight. All right, so that's being said, let's finish up with our beam. Okay, so here is our beam. The dimension from this to that into in is 2725, and I'm going to be using that. So if I click on this same area tool, volume in cubic meter, then what do I want to measure this time is my beam. Let me add the staircase. Beam staircase. Okay, what's my depth? The depth at this point, like I explained initially, is not the 0.3. The 0.3 will be taken care of once I am able to hover around and then measure for this very single shape. Okay, but the depth here is going to represent my length of that beam, and the length of the beam is at same as 2725. Okay, then I click OK. Then here is the beam. Here is the beam. So I click. You can see that this my line is going in a zigzag motion. So what I have to do, you remember what I did initially, I turned off my auto. So click my backspace twice and turn on this very auto, and once I turn it on, these my, you know, edges are able to snap correctly to each and every of this end. All right, so with that is 0.2 cubic meter. And lastly, I will be adding my concrete base, that is the base of the staircase, to that. So I'll click on the edges to add that, then this edge, and lastly double click, and you have a total for the staircase base and that of the beam to be 0.7 cubic meter. And that is all about your concrete work for your staircase. If you have any question, do always leave your question on the comment section, and do not forget to subscribe, like, and share our videos. Thank you. Again, this is another page showing us the reinforcement detail for this same staircase. All right, you can see the same arrangement for our flight and the same arrangement for our reinforcement details on the plan of the drawing. Okay, so there is something I want you to pay very much attention to. Any reinforcement, you can see that this reinforcement will have the one that are being arranged. As you can see, if I zoom in, you can see there are ones that are being arranged along the flight. There are ones that are also along the same flight, and there are ones or this reinforcement that are across the plan. All right, so if you see any reinforcement that is across the plan, you will always measure that on the plan. But if you see any reinforcement that is along the plan, please use the section to measure that. For example, if I zoom in, you can see our bar 12, you can see our bar 19, you can see our bar 03, our bar 02, our bar 04, and 02 here. All of these bar should be measured, on the section. But if you have every other one that is across the section, please always stick to measuring them on the plan. So that is the tips that I want to give us, and then you should always pay attention to that when you're taking measurement for your reinforcement. Another thing I want us to pay attention to, these very initials that are pointing towards the reinforcement bars. This 9 here is representing the number of each of these reinforcement bar. This is a high yield reinforcement bar, so you have to pay attention to this. This is 9 number of this diameter. The diameter here is 12, so high yield reinforcement, and the diameter is 12. Then this is the number or the initial on the bar, for you to be able to know that yes, you are referring to bar 11. This is actually the serial number on each of those bar. Then the 150 here is talking about the spacing, the spacing, and the BB here is talking about the location of the reinforcement bar. Okay, so you pay attention to that. More to what I have just explained, there is this particular label that I want you to pay very much attention as compared to the others too. Those are the numbers on each of those bar, not the serial number now, but I'm talking about the number on each of those bar, or the number of each of those bar that carry the serial number. Okay, like the 9, the 16, and the 16, the 9, and the 9 by my left hand side. At this my right hand side, I have 6, 15, 9, 9, and 15. Okay, with that being said, I'll be using my linear tool to take care of or to take measurement for my reinforcement. When I go ahead to click on my linear tool, then I'll have this prompt, and then you can see that whatever I'm going to measure this time is going to be in meter by default. Okay, so I will have to go to advanced. Okay, let me type in first. The first thing I want to measure is my T12, the ones that have 9 attached to them. Okay, T12, and then I go to advanced, and from your advanced, let me bring that down a bit. You can see that I have my quantity takeoff to be in meter, just like I've said. But also there is something we need, because I want it to actually be easier for us. We can do all of our conversion within this very section, And if we're able to do that, we can always have our reinforcement either in kg or in tons. But for me, I want to go straight to have every of my measurements to be in tons. And what do I do this time? I will have to go to add property, and once I click on add property, what I want to measure this time, or what I want to add my rein, representing my reinforcement, to be in kg. Okay, and I'm leaving it on the group estimating. If you don't know how to use these particular advanced measurement or the advanced measurement tool, please, there is a video that have explained that, so please, I would advise that you should go through it and learn the basis of this advanced form of measurement so that you don't get confused along the line. Okay, then once I leave it on estimating group, I click OK. And once I click OK, the truth is that you might not be able to see it at this point, but there's this little icon which is my refresh icon. Once I hit on that, you will see that I have my rein in kg. Another thing I want to also have is my rein in tons. Okay, so I click on the add property again and then type in rein. This time the unit is going to be ton, and the grouping is also in estimating. Then I hit OK, I refresh, then I have these two parameters added under my estimating group. Okay, so what I want to do is that I want every of my takeoff, so I will cut this and then paste it on my rein kg. I'll paste it here, and once I paste it here, for me to convert my T12 to kg, I will need a particular multiplying factor, and that multiplying factor, you can go about knowing that easily by saying the diameter by the diameter. You multiply the diameter by the diameter and then divide by 164. That gives you the particular multiplying factor you're looking for. And if I do that with if I say 12 multiplied by 12, as I am using the diameter of 12, if I say 12 multiplied by 12 divided by 164, it's going to give me 0.878, which is going to be 0.88. So I go ahead and click on my mathematical sign, which is division, and then I type in 0.88. okay, so what is my unit at this point? My unit is going to be in kg, so I type that. Then my reinforcement in tons. How do I get my reinforcement in ton? My reinforcement in ton is going to be measured. If I have my reinforcement in kg, what I will do is carry my reinforcement, drag my reinforcement in kg, then I refresh, and then click on my mathematical sign. I divide that by 1000, and my unit is going to be in ton. Okay, and I discovered I've made mistake here. This is actually going to be, since we have divided with 164, this is going to be actually multiplication. So this is multiplication sign. We multiply the takeoff with the multiplying factor and then divide with 1000 to have our reinforcement in tons. Then our quantity is now going to be our reinforcement in tons. So I'll drag my reinforcement in tons and drop here, and also change. I can refresh and have it there, and then I can change this to be in ton, as you can see, and that sorts every other thing that I need, and then I hit OK. So at this point, whatever that I'm going to measure this time is going to be in ton. So I would advise you go through this again and understand what I just did, so that your reinforcement will automatically be converted into ton and not meter this time. And remember what I told you, or the tips I gave you initially, that if you have any reinforcement across the plan, that you should always measure with the plan. But if you have any reinforcement that is along the plan, that you should always measure from the section. And if you look at this, our section X101, you can see that we have this reinforcement with this serial number 02, 03, 03, 02, 04. Okay, for example, using this reinforcement that has the serial number 02, if you try to locate this is actually along the flight. And if we check from this very plan, if we check for 02 bar 02, this is our bar 02, this is our bar 02 here, and if we trace that, you can see that our bar 02 is spanning all through the length of both the flight and the landing. All right, so you are not going to measure from the plan, rather you're going to measure from the flight. Okay, so using that as an example, let's go ahead. What we're measuring on is the ones that have 9 as the number. So once I click on my digitizer, I will go ahead and measure that. Let me zoom that a bit, and I'll start measuring from, okay, this is our bar 03, so I will start measuring from this point. Again, if you want to measure your reinforcement that is with curve, there is a way to do that. There is no difficult moment at all that you should have. What you should do at this point is to click at this point, then click on your keyboard, on your hard key, click A, and then you see that there is a point that is now saying click middle point of the arc. Of course, this is an arc. If I zoom in, you can see that this is an arc, so I'll click the middle point. And where again do I want to click? I want to click on the next point, which is here, and then I keep on doing that. At this point, I'll click here, I'll click on the hard key A and click on the middle point, then the next point. Continue with my measurement, click on this point, click on the hard key A, and I form my arc, and then click on the next point, and I continue my measurement. Okay, so I will zoom to be able to cover up for all the areas I'm supposed to cover up. So I have a kind of overlap here, but my bar 02 continued all the way through to this end. So here is where I will terminate my measurement. Okay, so I double click, and that is all for my bar 02. Okay, you can see that the reinforcement bar was spanning through, or is spanning through from the flight all through to the landing, and that is the same thing that we have here. So it didn't just start from the landing even, but is from the landing going towards the flight and then on the staircase base. All right, so that is it. And you can see that on my left hand side I still have 0.0 ton. Whenever you convert anything in ton, if you have a particular dimension in kg, if you divide by 1000, the value is going to be this minimal. But as we keep on adding to this very value, you see that we're going to have a particular value that is not going to be 0.0, okay, 0 ton, as we have on this particular place. Okay, then let me measure for my bar 03. I zoom in again. My 03 is spanning from here all through to this very end where there is an overlap. Okay, so I will zoom in to be able to click at the point where I'm supposed to click, and again, okay, my reinforcement is, there's overlap here, but my 03 span all through the way to this point. So here is where I'm gonna stop. Okay, if I try to add any bar that is across the plan, for example, this time I want to assume I am adding this particular bar that is on the landing to the value. I just want us to confirm that yes, there's a particular value that is being added to this 0.0 ton. Okay, so if I click on this side and also this side that have been added, and then there's another bar across this side which is from here and spanning all through to this place, and then I've added that also. We also have other smaller bar. Let me turn on my auto so that I will have straight line. Okay, and we have this. We also have this. Then we have this. This is just an example that I'm showing you, but you can see that this particular reinforcement bar that I'm adding to the one that have the initial 9 is not actually with those initial 9, so you can correct that on your own measurement. I just want to confirm that yes, that we have a higher value, so you can see that we will now have 0.1 ton on this side. Or another thing you can do is right click and go to property, and then you can see if you go to advanced, you will discover that you have all the value, both the one in kg. In kg is 49.01, and then in ton is 0.05 ton, and that is what it have, added up to be 0.1 ton. Okay, let me click OK. Again, you might be wondering why I had to enter 9 before T12 as I have on the drawing or on this page. Why I'm doing that is so that it's going to be easier for you by the time you are transferring your value from your report end, that is from here, or when you want to export to your Excel. Okay, let me show us what I mean by that. If I come to my estimating, this is what I have measured, and here is my reinforcement. But there is a particular, button that is export to Excel. Once I hit on this export to Excel, my Excel is automatically, launched, and once I open that, you will see that I have let me maximize that. Okay, you can now see that I have 9 of T12 to be 0.5 ton, which was approximated to be 0.1 ton. And what you can do here using this very 9 is that you can know that there is 9 number of 0.05 ton. Okay, that is just trying to make it much more easier, to that. So once you click on this cell, then you can always do the needful equals to but this time it is going to be multiplied by 9. So hit enter, you can now see that the total value now is 0.545 ton, and it's a way much easier how to manipulate and change all of these things. It's not a problem again, but the main thing is that you've never to measure for your reinforcement, and that is why I had to add up this 9. So for the ones that have 16, you're going to do the same. You're going to multiply by 16, and I believe this video was helpful. If you have not yet subscribed, please subscribe, like, share, and if you have anything that is not clear, you can always ask a question on the comment section and we will have it attended to. All right, and thank you for sticking this long on this very video tutorial.